inyong lahat. Para po sa ating mga viewers sa Facebook Live. Naka-Facebook Live tayo, no, partner? So, magandang umaga po sa inyong lahat. No? So, today we will discuss electrical transients. No? So, the basics of electrical transients. Okay, so, may we request for our viewers sa Zoom natin to open your camera, your video. Please, guys, now please open your videos. Okay. So, how many viewers do we have in Zoom? Okay. Sige po, paki-open lang po natin. Partner, ganun ulit yung setup yung kahapon natin. Okay. Sige po, so, you're going to discuss electrical transient. So, okay, so the first topic is about the series RC, no? We'll discuss this, no? And then the series RL and series RC, no? So let's go over to our PowerPoint. Okay, so we have electrical transients. Kunin natin, let's see. Para makita rin ako. Ano natin. Okay, then makikita rin itong ano. Let's make it 2-in-1. Nakikita ko and then nakikita rin ng mga students yung ating PowerPoint. Okay. So, electrical transient. Okay, let us discuss this. So, it is a short-lived oscillation, no? In a system caused by a sudden change of voltage, current, or load, no? So, if we mean transient, there is a short-lived, no? Ibig sabihin, maikli lang, no? It's a short-lived oscillation. Oscillation meaning there is a changing in magnitude or in value, no? Of our, let's say, current or voltage, no? Or even power. So, it is a short-lived. So, that is caused by a sudden change of voltage, no? So, sa ano natin, in our system, there is a sudden change in voltage, in current, no? And of course, our load, no? So, okay, sometimes we are on a peak load, sometimes we are on a low load, no? Or a medium loading, no? In our system. So, it depends on our usage, no? With respect to time. Okay, so, another definition of electrical transient, it is a temporary phenomenon occurring in a network prior to reaching a steady state, no? So, it is a phenomenon in an electric circuit, no? So, prior to reaching the steady state. So, it means, no, there is a situation, an initial, no, phenomenon happen in an electric circuit. So, there should be a time to adjust. Let's say it's in layman's term, that is the transition period. So, you are waiting to adjust, no? Before you go to a normal stage, no? So, there is no airplane that it will fly from the ground, it will go like this. Right? So, wala namang ganun, no? Bigla namang umandar na ganun, no? It's like in Star Wars. Okay? So, there's no such thing. So, it will fly slowly but surely, no? Until it reaches its steady height, no? With respect to the ground, no? Okay? Or to the earth. Okay. So, just like also in generator. In generator, there is what we call a built-up voltage. Let's say the rating of your generator is 230 volts. Or high voltage, let's say you have a 13,800 in power plant, no? When you start a generator, it will not give you 13,800 right away, no. It will, there is a stage that it will build up before it reaches your normal value, no. So there is what we call a building up process for our generator, no. There is a build up process. Okay, so that is considered to be in a transient stage, no? Okay? At transient period is the period required for the currents and voltages to adjust. No? Meaning, a transient period is a period of adjustment, no? themselves to the steady state after it is switched on. No? Okay? Just like in a, they call this, yung nagliligawan. No? Siyempre, ano muna yun? Nagliligawan muna yun. What's that in English? The courtship period. No? So, before you get steady, of course, there is a stage wherein you adjust to each other. So, there is a period of adjustment. No? Until you reach, you are already steady. No? Steady state. No? Okay. So, in general, transient disturbances are produced whenever. Okay? What causes transient? Number one, an apparatus or circuit is suddenly connected or disconnected from the line. No? So, especially in a large-scale system, no? Commercial, industrial building. No? Okay? Please show number 2 and number 3 in our PowerPoint. Okay? Okay, just a little. Just a little. Okay. Number 1, the apparatus or circuit suddenly connected to or disconnected. Suddenly connected or disconnected from the supply. No? Even in our house, no? Sometimes if you on a set of lights, no? There is sparking in our switches. So may spark kang makikita doon, no? Okay? Especially in our industrial plant, no? You have a large load, especially if you have so many motor loads, no, in industrial plant, no? When you turn on, no, sometimes in our switch or disconnecting switch, there is a sparking. And when you turn it off, no, when you open and when you close, then when you open the switch, there is still sparking in the contact. No? I remember when we are experimenting in the school, no? So we connect the motor generator set, no? We on the night switch, okay? Then once we turn off, no? We disconnect the line. There is a, actually it's not that sparking, it's a there is not only sparking, a little fire on the contact of the switches, no? And that is just a small scale circuit. So much more if you have a large, let's say, in a substation, no, or in a power plant, no? There is really the effect of arcing, no? Okay, or arcing effect, no? And number 2, short circuit, no? Okay, the circuit is shorted. If the circuit is short-circuited, no, so that gives you a lot of value for your current. The magnitude will become too high, no? Okay, will be discussed. We are going to discuss that in our subject in a power system, the short circuit. By the way, next week we have a short circuit calculation topic, no? Webinar, no? Next week. Okay, just later. I'll discuss that with you. So, there is a sudden change in the applied voltage. No? There is a sudden change in applied voltage. Ibig sabihin, mabilis yung pagbabago ng voltahe. No? Okay? There are so many reasons why the voltage changes. I have a separate, well, that's a free webinar, no? Entitled Power Quality. You may attend that for free about power quality. I'll show you many reasons, no? The reasons why voltage suddenly changes or changes its magnitude, no? Okay, from one finite value to another, no? And also, if you have, let's say, a capacitor bank, no, when you turn it on and turn it off, there is a transient effect, no? Okay, even if you have a large transformer, no? Okay, based on my research, a large transformer, it can have a very high inrush current. That is a transient current, no? The inrush current is the current when you start, no, the starting current. It is also known as the starting current. This is the inrush current, no. Both motors and transformers has inrush current. The motors may have 5 to 8 times, no, of the full load value. Let's say if you have a 100 ampere motor, it can have 500 to 800 ampere on the average. If you have a transformer, that is bigger than that, no? Okay. When you start a power transformer, especially in substation, in the power system, so the transient current is very high. Anyway, we'll be talking only for this topic the direct current transient, no? So the DC transients. Okay, types of transient. We have the single energy transient. So these are those in which one form of energy, either electromagnetic or electrostatic, no, is involved, as in RL and RC circuits, no? So if we mean electromagnetic, that is the energy stored in the inductor. If we mean electrostatic, that is the energy stored in the capacitor, no? Okay? So, yun ang nai-store ni capacitor. Sir, what about resistor? Do resistor store energy? No. The resistor dissipates energy. There is a power dissipation, no? He utilizes the energy, wherein a capacitor inductor, you may store energy on it. Basically, that is the reason when you turn off any appliance that has an LED, no? Let's say you have a television that has an LED, then you turn off the supply, no? Okay? You pull the plug, no? Well, if you pull the plug, you pull it, you handle the head, not the cord, no? That may damage the connection, okay? So, you better hold the head of the plug itself, no? When you disconnect, no, your television, there is still power on the LED. Although the television is already disconnected from your source. Why is that? It's because, no, your television has a power supply, it has a capacitor in it. So there is a time to discharge, no, its electromagnetic energy. That's why there is what we call the lagging effect, no? There is still power or voltage stored in the capacitor, even though when the line is disconnected, no? Okay, so the effect of transient is present only in inductive circuit and capacitive circuits. Double energy transients. These are those in which both electromagnetic and electrostatic is involved, as in RLC. So, well, double energy simply means, no, it is called single energy because it is either RL or RC. But if you combine already the L and C, let's say you have a series RLC circuit, that is already called as a double energy transient. Keep in mind that, no, there is an opposing effect between the inductor and capacitor. They oppose each other, no? We will study this in power factor correction. You have so many motors, no? You have so many motors, your power factor goes down. What is the effect? No? The effect is, no, you draw a large amount of power or kVA from the source. And also you are drawing a large amount of current from the source. You are getting a large amount of current from the source if you have so many inductive load. Okay? As a remedy for this, as a solution, you better connect a capacitor because it is a reactive power generator. No? So, if you connect a capacitor, this compensates the loss. No? This lessens the loss, and the inductive power drawn by the load becomes lesser. because capacitor generates a leading K-bar, a leading reactive power. Well, we will discuss this in power factor correction. We have a separate, again, a free webinar for that. That's free. Okay, so next slide. Okay. So, transient in DC circuit, we have time constant. The time constant is defined as the time when the magnitude of the exponent of E in the current formula is unity. May I correct this? We will study this later with our example. It should be the magnitude of the exponent of E in the current formula is, it should be is negative unity or negative 1. I'll show that later. The time constant is L over R, no? For series RL. The time constant for RC is RC. Simply RC. It's like RC cola. Okay? So, next. This is the transient behavior of the inductor and capacitor. I want to go first with inductor. Okay? Let us have in the board this. Let's go with series RL. Okay, let's go first with the transient behavior of an inductor. Okay, so by the way, I will put a switch here. I have to put a switch. I will transfer this current here. Our current I. Then I will put a switch here. Okay. There is a boundary condition, no? At time t is equal to 0. When we say time t is equal to 0, that is upon switching. So at time t is equal to 0, no? Inductor L is open. Oops. By the way, this is a DC transient. Sorry. I correct this. Okay. L is open. L is open. Okay? L is open. That is upon switching. What do you mean by upon switching? It is the time, no? When this switch contact first touches the first time it touches this contact of the line. This is the contact of the switch and this is the contact of the line. No? The first instant when this contact of the switch touches the contact of the line, that is at t is equal to 0. L is open. Our L is open. Okay. At L is open, no? At time t is equal to 0, okay? There is no current yet. There is no current. Why? No? I is equal to 0. Because that is the behavior of the inductor. It becomes open at time t is equal to 0 upon switching. That is the behavior, no, of the inductor. Okay? Okay. When at time is equal to infinity, okay, switch is closed. If we mean time is infinity, that is steady state. At steady state, no? You may copy what's on the board. Okay. Inductor is shorted. Okay, if that is shorted, okay, what can you say if the inductor is shorted? Okay, I will put a short-circuiting conductor here. What can you say about our I? What is the value of our current? If this is shorted, the current, of course, the switch is closed here, already closed, no? We already closed the switch here. So, the current will flow continuously. But take note, this is short-circuited. The current will flow in the short-circuiting conductor. It will not flow anymore to our inductor. It will not flow to our inductor. Because we have a short-circuiting conductor here. No? Okay? There is a short-circuiting conductor. So, what will be the value of I? It's just simply, no, the V or the voltage E over R. Okay? Sometimes this is B. No? We can use B, we can use E. There's no problem about that. Okay? This is the reason why transformer, no? You see this one, L is shorted. L is shorted here. This is the reason why transformer can never be operated in DC. It is because a transformer is an inductor. An inductor is shorted at steady state condition. It will not, you cannot use. That is why transformer is a type of AC machines. No? It uses AC, no? And it delivers AC. No? Alternating current. Well, there's another reason why transformer can never be used in DC. No? This formula. Take a look at this formula. We discussed this in our DC circuits part 2. dP over dt. This is the Lenz's law equation. No? Transformer can never be operated in DC because this induced EMF, let's say in your transformer, the dP over dt is 0. Why is it 0? Because you use DC. Remember that the magnetic flux is dependent, no? From the study of electromagnetism. Electric flux is dependent on the current. You remember the Ampere's right-hand rule in the direct current part 2. If this is the direction of the current, no, this is the direction of the magnetic field on a clockwise direction. No? Direction of the current, this is the magnetic field. More current, more magnetic flux. That is directly proportional. It depends on the flow of current in the magnetic field. No? The magnetic flux is dependent on the current. No? Okay. Transformer can never be used in DC because there is no change in magnetic flux. Why? Because DC has a constant value. It doesn't change. In other book, that is delta, right? Delta. No? We may replace the derivative into change. Change in flux over change with time. Because there is no change. The initial and final value is just the same. How are you going to, if you subtract these two values, if they are just the same, that is zero, right? You cannot generate voltage. Okay. So, let us have this. Let's go over in the PowerPoint. This is just an example. I saw this in the, based on my research. So, this is from 0 to 10 ampere. So, let's say this is 100%. This is 100%. So, there is a growth. No? Okay? Take a look here. This is what we call the one-time constant. The time constant for RL is L over R. This is 6.32. That is with respect to 10. If this is 100%, this is 63.2%. That is one-time constant. Okay, then there is 2-time constant, 3-time constant, 4-time constant. When it reaches 5-time constant, then the circuit is already in steady state condition. That is quite a shortcut, no? This figure. We don't have a steady state here. So, wala yung steady state. So, growth muna, hindi naman decay agad, no? So, dapat steady muna. So, parang ganito. So, please take a look here. Okay, a DC circuit, no? Series RL. We have the transient period, and then the steady state, and then there is a decay, no? I hope this will not happen to your relationships. Okay? This is decay. Okay? So, it's better always we have the steady lang. Okay? Steady lang tayo dyan. Okay. So, let's go here. Okay, series RL. Okay, so, I want to make a little derivation on the formula of the current. On the formula of the current here. In the current formula in the PowerPoint, let's see here, our I will be equal to V over R, okay, then times 1 minus E raised to negative R over L times T. Okay? Okay, so take a look at our circuit, guys. Let's take a look at our circuit. This can be E, no? I will make this as E. For the meantime, we have our E here. So, our total voltage E is equal to VR plus VL, right? Okay? Powerhouse chop-chop law. The voltage here plus voltage here is equal to the voltage here. Okay? So, we have our VR. No? Our BR. So, we have here our E is equal. What is BR equal to? The voltage across the resistor. That is simply equal to I multiplied by R. Plus, what is our BL equal to? That is L, derivative of current with respect to time. L di over dt. Okay. Let us make use a little differential equation here. So, this is our E. Okay? Let us lipatize, no? You know lipatize, no? Lipat, no? Transpose. Okay. So, minus IR. Okay? That is equal to L di over dt. Okay? Please close up this portion. Close up mo dito na. Okay. Pati medyo ibaba dito. Okay, so, we have what now? Okay, so, by variable separable, this is di, there is I here. Okay? So, by variable separable, so I will have this dt, no? dt over n. Okay? Okay, cross multiply this dt here and the L. And we have our dt, di. What is our di equal to? Di is what? Di over e minus ir. No? That one. So, may I rearrange this? No? So, I will have first our di here. Okay, please close up this portion. Okay, dito, close up muna lang. Yan. So, di over e minus ir. Okay, that is equal to dt, no? Over L. Okay, so this is variable separable. No? Okay, so what do we have here? Let us integrate both sides. Integrate. Let us integrate that. Okay? I remember in integral calculus, no? So integral of du over u is equal to ln of u. Okay? Later I just we'll just put the c. ln of u. Actually, there is plus c. Okay. So the derivative of u is du. Our u here is our e minus ir. But what is our du? Of course, it should be with respect to I. If that is with respect to I, no? So, this will become what? Derivative of u is equal to what? No? That should be negative r, then we have here di, right? So, there is a negative r. No? This one. So, we have negative r. So, we have to balance this. If there is negative r here, put here negative r. Right? So, ganun, di ba? So, we have that. So, we are now ready to integrate. Huh? So, please focus your camera here. So, this will become what? This will become ln, no? Or ln of what? E minus IR, no? E minus IR. Okay? So, that is equal to what now? This is dt. This is just constant, no? It's simply t over L plus C, right? This is plus C. Okay? Oh, by the way, we have still 1, no? 1 over negative R. Okay? Let us multiply both sides by 1 over negative R. No? Okay? So, we have this one, no? This one. Because of 1 over negative r here, no? I will multiply both sides by negative r, by the way. Let's multiply both sides by negative r. Okay? You see? Okay, let us multiply both sides by negative r. What will happen? See the equation? I hope you can, you are copying also what's on the board. Okay? Okay. We have negative r here. Of course, this will cancel out. What will be left here is our ln of E minus IR. Okay? So that is ln of E minus IR. So that is equal to what, guys? This will become a negative RT over L. That is, well, this is a constant. Let's say this is any number. No? Assume any number here. But this is still constant. No? Okay? A constant is assumed to be a large number. No? Large number. What are we going to do here? Take the exponentials of both sides. Take the exponentials. This one. Take the exponentials. So, you'll be having here an equation of e raised to ln of E minus IR. No? If you have this equation, no? Okay, it will just become E, no? Minus IR. Okay? How is that? Let's say you have your L. Okay? A is equal to what? E raised to ln of A. If this is A, this should be A. Let's say you have your X. That's equal to E ln of X. If you have your X here, that is X. If you have your Y here, that is your Y. Okay? So, let's go over here. E minus IR. So, this will become what? So, I already considered this portion. What about this portion? So this is our E minus IR. So that is equal to E, no, raised to negative RT over L. Okay. Then if you are to take the exponential, there is here a plus E raised to C. Plus E raised to C. No? That will become E raised to C only. Why, sir? Why? Because in algebra, no? Okay? They have the same base. If they have the same base, no? What are you going to do in the exponent? You add, right? That is in algebra. Okay? That is why this is addition plus C. But in here, it should be multiplication. Okay? One. Did you get that? Is that clear? Is that clear? Okay, that's clear. Okay, that one. Now, we have a boundary condition. At time t is equal to 0, our current is equal to 0. But take a look here. Take a look here. If our time is 0, okay, our current is 0. Our current is 0. So what will be left in our equation here? Our E now will become what? Please focus this in the camera. This one. So this is already 0. This is already 0. Oh, by the way, E is a certain number, right? There's a value for E. Any number raised to 0 is always equal to 1, right? That is by algebra. This E raised to 0 will become 1. Now, what is E raised to C? E raised to C is a constant. You may represent that as just simply C. Okay? So therefore, our voltage E simply equal to C. So therefore, we may write this equation here. This focus here, E minus IR, okay, that is equal to, okay, I will, remember, our E raised to C is simply equal to C. So if that is equal to C, I will put here E, and then we have here E raised to negative RT over L. Okay. So, let us get the equation for I. How is that? So, we have here, no? We have here our I. Let us lipatize, no? Lipatize, transpose, okay? Let us transpose this so that this negative will become positive. And this positive will become negative in here. Okay. So, we have here our IR. So, that is equal to what? That is equal to E. Okay. So, that is minus E times E raised to negative RT over L. Okay, now, I will factor out E. We have our IR. So, our E will be factor out 1 minus E raised to negative RT over L. No? So, therefore, our I will be equal to E over R. Okay? Multiplied by 1 minus E raised to negative RT over L. So, therefore, this is our equation. Did you get that? Okay? So, that is our equation for the current. Okay, let's go over with our PowerPoint. Take a look here. So, we have our VR. Where did we get our voltage at the resistor? Please take note. Go over here again. Our voltage in our resistor, I will cross-multiply R here so that it will become IR. By the way, what is our IR? That is the voltage in the resistor, right? So that is equal to our E times 1 minus E raised to negative RT over L. No? Okay? So, I may replace our E with V. No? Kung gusto mo, V. Okay? You like V? O make it V. Or the total voltage. That is the total voltage V. 1 minus E raised to negative RT over L. Please take a look at the PowerPoint. Will it give the same equation in the PowerPoint? The answer is yes. Okay? And then this is already a formula. BL is LdI over dt. Okay? Or, we have this equation. How did we get this equation? BL, please focus this. BL is the total voltage E raised to negative RT over L. No? So, where did we get that equation? So, that is the equation for the voltage in the inductor. Voltage in the inductor. No? So, take a look here. Take a look here again. In this equation. This is our equation here. No? I will cross multiply, I will distribute this total voltage here. Okay? So, the equation would be VR. So, that is equal to V minus V E raised to negative RT over L. Okay. Now, I will transpose this. This is VR. This is total voltage. This is VR. Okay? Negative will become positive. So, V, E raised to negative RT over L. But who is this? Who is this? That is simply our BL. Right? BL po natin yon. Ayun, no? This is the total voltage. Okay? So, therefore, our VR plus BL is equal to total voltage V. Okay, let's go over again. So, that is the equation. No? So, ito yung equation natin. BL is equal to VE raised to negative RT over L. Babalikan natin mamaya yan. No? Okay? We will use that later. Okay. Okay, so let us have a review. I will take note first. Please make a little focus here. So this is RL circuit. This is curve A, this one. This is curve B. Inductor, current, or resistor voltage on build up. No? Let's say this is curve A. This is on build up process. process. Now, the inductor current or the resistor voltage builds up, no, initially. Okay. Then, curve B, this is curve B. The curve B, inductor current or resistor voltage, decay. No? It decays, no? Until it goes to zero. That decays. No? Nagdi-decay na siya. Okay? Okay. So, let us answer this problem. Okay. Before I answer this problem, please focus your camera here. Anak, ito. Para makopya nila. Baka may gustong kumopya ng derivation natin. Kung pwede, dito sa portion na to. Tandaan lang. No. This portion. Yan. Pati ito, makuha. yan. Okay, focus na lang ako. Okay, let us have this example. But by the way, we would like to greet our viewers in our Facebook, no? So as of today, let us
10:31
have an update. How many viewers?
9 po. Sa Facebook po
Facebook?
is 26.
26. Okay, so good morning to all of you. So for our viewers in our Facebook Live, no, we are live na live, no? So live na live po tayo sa Facebook, no? So what is the day today? Today is July 3. Time check, partner.
10:31 a.m.
Ha?
10:31 a.m.
10:31. Okay, 10:31. So live na live po tayo. This is a free online review, no? So this is brought to you by MPHT Review Center, the Marinais Powerhouse Team Review Center. Okay. So magandang umaga po sa inyong lahat, sa ating mga late tuner, late viewers, no? So ito po ay isang live online review na libre na pinagkakaloob po ng MPHT Review Center sa inyo, or just simply Powerhouse, or MPHT is Marinais Powerhouse Team Review and Training Center. So ito po ay libreng review na po pwede nyo po ring i-view po sa ating sa aking pong YouTube channel, no, yung Reggie Marina YouTube channel. So please subscribe to my YouTube channel, no. So okay, let us continue our discussion about the series RL DC Transients, no. Okay, so let us have number, is that 1 to 8 only? 1 to 8? I thought it is 1 to 9. Okay, 1 to 8 here. Okay, anyway, a series RL circuit is energized by constant 24 volts, no? So we have 24 volts. DC source applied at T is equal to 0. If the resistance and inductance are respectively 10 ohms. Okay? Our resistance is 10 ohms. Our inductance is 1 Henry. Okay. To all our students out there, so good morning to all of you, no? So magandang umaga sa inyong lahat. So if we have a let's say a third year student, no, this is a very useful for you, no? This is actually an online review, no? Live na live po tayo. Okay, so question, no? So these are the given, no? The voltage 24 volts, no? Resistance 10 ohms, inductance 1 ohm. So let us answer the following questions. What is the equation of I? Okay, for number 1, our I, okay, simply equal to, what is the equation again? V over R times 1 minus E raised to negative R over L times T. So ito yung equation natin. Let us substitute, no? I simply equal to, what is our V? 24, our resistance 10. So we have 1 minus E raised to negative 10 over 1. Okay? And then let it be T. Okay? So our I now will be equal to, so 24 over 10, 2.4, 1 minus E raised to negative 10 T. So that will be our answer, no? Okay? So this is our answer for number 1. Okay, so let's see for our PowerPoint. No, what letter is this in our PowerPoint? Okay. So the answer would be letter D, no? So it's masyadong maliwanag. Okay. So anyway, nakita niyo naman yung sagot dito sa ating ano. Bakit gano'n? Sobrang liwanag siya. Okay. Maybe that is the effect of lights, not? Okay. Anyway, I already write it down here. Okay, I'll just put the letter of our correct answer. Letter D. Okay, let's head now number 2. These are the follow-up question. Okay. The time constant L over R for an RL circuit is the time required for the current to reach how many percent, no? Although we all know that this is an objective type of question, but I'll show you how did we arrive with this answer. Okay. Hindi makita eh, no? So, makita natin. The answer would be 63.2. In the board exam, that is already an objective type of question for it. No? But how did we arrive with 63.2%? Okay, let's go over on the board. Again, our formula is B over R. Actually, guys, no? What is B over R? What is B over R? Sir, that is the current. Yes, that's true. No? The B over R, if we have here a DC transient, so we have this is a straight line. The B over R is this value. B over R is this value. Ito yon. That is already our steady state current. Steady state. Steady state current. Okay? The B over R is this. Okay? Ayan, no? So, the time constant involved. Okay. So, we have I that is equal. Please focus your camera here. Okay. So, we have 1 minus E raised to negative R over L. Okay. Our time constant, no? Okay. Our T here is equal to time constant, which is L over R. Right? L over R. So what happened is that this L will cancel out. This R will cancel out. What? It will give you a value of negative 1. Right? Did you get that? Because that is just cancel out. Okay? Okay? So therefore, the exponent of E here is not 1. It should be negative 1. Okay, let's continue. I is equal to B over R times 1 minus E raised to negative 1. Okay, in your calculator, will you do this in your calculator? Come on, I hope everybody has a calculator, our viewers there. Okay? To all our students out there, so use your calculator. What will be the value of this? 1 minus E raised to negative 1. What is the value for this? The value for this is what? 0.632, isn't it? Did you get that? Thumbs up nga kung nakuha. Sino nakakuha sa inyo dyan? Thumbs up. Yun, nakakuha ni Kim. Oh, good morning, Kim. Ito, estudyante natin to si Joel, no? Ito, pinakamayaman nating estudyante, no? Biro mo, Joel Cruz, Di ba? Di ba Joel Cruz yung, yung may-ari ng, yung pabango, di ba? Kilala mo yan, Joel? Di ba? Joel Cruz, yaman nito. Okay. Good morning po, and meron din tayo, bago yata si Andrea, Pauline. Good morning, Pauline. Kaklase mo ba si Kim, Angelo? Kaklase? Bit-bit mo yan, Kim? Ay, salamat. Ha? Magkaklase ba kayo? Kaklase mo. Okay. Parang magkahawig, ha? Okay, magandang umaga po, Sir Leoncio. Magandang umaga po. Espra Junior. Okay, Sir Jun. Good morning po sa inyo. Okay, si Sir Jet nandyan. Si Patrick nandyan din ng Bulso. Okay, good morning po. Sesya na iba, hindi ko po mabate, ha. Okay, so punta tayo dito. No? 0.632. Okay. Doon galing yung 63.2%. Okay. Well, of course, kung itanong na to sa board exam, that is already an objective type of question. That is being asked in the licensure exam. That's very easy. Okay. Number 3. Number 3 is the current when 0.037. What is the current? You just have to substitute, no? 2.41 minus E raised to negative 10 times 0.03. What is the value? Let's go over with the PowerPoint. Sige nga, I want everybody to participate guys. Not just like in our classroom at Powerhouse. I don't want I don't like I'm just only the one solving the problem, no? ako lang yung nagdadaldal, no? I'm just only the one talking. I don't want that way, no, in my teaching, no? My way of teaching is interactive. That is why, thank God, we set up this kind of setup, no? Sa tingin ko nga, no? Siguro, there. You compare the system of the other centers, no? I think we are the first review center to come up with this kind of setup. It's an interactive, no? Sa iba, nakita ko, partner, ano lang no? Yung parang PowerPoint lang nila doon, tapos yung teacher, ang liit-liit, no? Daldal lang ng daldal. So, tayo po hindi ganon. This is like in a classroom, no? So, okay. Sige, ano sagot natin? Anong letter ang sagot natin, partner? Okay, yun. Yun ang problema, no? Effect lang po ng lighting ito. The answer is 0.62. Anyway, I will write it down here. 0.62 amperes. Anyway, makikita naman nila doon no? So the answer will be letter C. Okay? Again, in our PowerPoint, okay, 0.62. Okay, that's correct. Right? Kaya, next number 4. Okay, eto naman, baliktad. Ang hinahanap naman yung time. So what is our time? Or number 4, time when? Okay. So in our formula, current is 1 ampere, no? That is equal to V over R, that is 2.4, no? Then 1 minus e raised to negative 10t. Okay. Just shift solve. What is the answer, guys? Please. Okay. What is the answer? Later, we'll have a short break, no? I think it's quite hard for everybody, especially with our listener, our reviewees, no, to digest right away so many topics to discuss. So we'll give you time to digest the topics. No, it's quite hard. No? You feel bombarded of those topics. So it's quite hard. So mahirap 'yon, no? Masakit sa ulo. Kaya magkakaroon lang po tayo siguro mga 20 minutes break lang, no? So to give them time to digest our lecture. So because it's quite ladderized, no? So mahirap kasi pag hindi nyo kagad na intindihan yung una, tapos dagdag tayo ng dagdag ng topic, so nababaliwala lang pagka ganon. Ano? So we'll give you time. We really need, according to study, ang what do you call this, ang comprehension daw ng mga estudyante, no, sabi is around 2 hours maximum. Pag lumagpas na daw ng 2 hours, hirap na mag-absorb yung brain. No? I don't know if that is true, but I just read, no, an article about that in the field of education. No? So that may be true. No, syempre pagod ka pag masyado nang mahaba, no? Kahapon nag-straight tayo, halos 4 na oras 'yun, no? Pagtingin ko sa video natin, kulang-kulang 4 na oras, no? So para ang gawin po natin mula ngayon, medyo may konti tayong break, no? Titigil tayo sa FB, panandalian. Then tutuloy natin after, let's say, mga approximately 20 minutes. Okay. So to give you time to digest the lecture. Even in Powerhouse, we have to make some break, no? So, okay. What is the answer here, guys? What is the answer here? Okay? That is the okay. Let's see nga, tingnan nga natin kung ano sagot nyo dyan. What is the time when I is equal to 1 ampere? Paano ko ba makakuha ng feedback? Pati nga itsura nila. Gusto kong makita dito. Sige nga, ano sagot nyo? A, B, C, or D? Paano kaya? Ganito na lang, ganito. Pag 1, A, ha? Pag 2, B. Pag 3, C. Pag 4, D. Ano sagot nyo? Sige nga. Para malaman ko lang, yun. Maganda may nagpa-participate. Yan, di ba? Ang sarap Sarap tumingin bakit yung isa, C? Tingnan natin, ha? Iba sagot ni Joel, ha? Iba talaga mayaman, D ang sagot. Talo si Joel, ha? Bawi ka, Joel, mamaya, ha? Okay. Very good. Okay. So, the answer is 0.05 second. 0.05 second. Okay. Anong letter ulit? letter D. Let's go to number 5. Number 5 is the rate of change of current when time is equivalent to 2 time constants. No? Okay, so let us solve this problem. No? Okay, so rate of change, meaning that is the derivative of I with respect to t. No? Okay, so the derivative of I with respect to t is equal to, okay, okay anak, paki-close up mabuti ha. So, B. Okay, what is our current equation, by the way? Our current equation is 2.4. 2.4. Okay. Derivative ng 2.4. Ano yun? Times 1. Minus e raised to negative 10t. Okay? That one. Okay? dt. O, paano gagawin natin dito, sir? Okay. O, conventional muna. Mamaya. Okay, dito muna tayo. Okay, 2.4 is just constant, no? Labas mo na yung, pag may constant, sipain mo kagad palabas, no? Sabi ng aking teacher, no? Okay. So, labas na yan. Okay. So, we'll be having here this equation. What can you recall in differential calculus here? That is the derivative of u, right? What is the derivative of u? Okay, dito tayo sa maliit na space dito. The derivative of u here, actually, this is derivative of e to the u. The derivative of e to the u is equal to e to the u times the derivative of u. Right? Left. Right, left. Right. Okay? So, 2.4 is just constant. Let us take the derivative of this. Anyway, what is derivative of a constant? 0. Right? Then, carry over the negative sign in here. What is the derivative of negative e raised to negative 10t? T is part of the exponent. There you are. This is e to the u. Wherein our u here is our negative 10t, right? Negative 10t, this is our u. Okay. I will just copy the negative, no? Because, take a look here. Take a look here. Yan, okay. E to the u. That is equal to e to the u. Let us just copy that because derivative of e to the u is e to the u. Let's copy negative e raised to negative 10t times the derivative of u. Now, what is the derivative of u? Where is u? Who is you? Who is you? Where is u? This is our u. Our u is negative 10t. So, negative 10t, let us take the derivative of negative 10t. It's just simply negative 10 in here. Correct? Did you get that? Okay, now, negative times negative, it is positive. That is positive. Negative times negative is positive. So, this is 2.4. Okay? Negative times negative, positive. Anyway, 10 times 2.4, that is just 24, right? I'll just put here 24. Okay? Negative, negative, positive. 2.4 times 10, 24. There you are. Then, we have here e raised to negative 10t. So, that is the, what is this? Okay, that is the equation. Right? di over dt. That is our equation here. Now, what is our time? What is our time? Our time is 2-time constant. Our time is equivalent to 2-time constant. You know the symbol of time constant, no? Some other books uses this symbol. That is a Greek alphabet. The Greek alphabet, tau. How do you pronounce this? tau. Okay. So, our T is equal to 2 times L over R. Let us substitute 2. What is our L? 1. What is our R? 10. So therefore, our time simply 2 over 10, simply 1 over 5. So we just have to substitute 24 e raised to negative 10 times 1 over 5. Give me the value here. Come on. What is the value for this? Please calculate. Everybody, I want everybody to participate. No? In Powerhouse, our student always has this calculator. Almost every meeting, we do some calculator techniques. Okay. Okay, I want everybody to give me the answer. No? Not later, I'll give you the right answer because I want to check if they are participating. Okay. What is your answer? Again, 1 is A, 2 is B, this is C, this is D. Okay. What letter is your answer in our PowerPoint? Apple, boy, cat, dog. Oop. Boy, nauna si Gwen, no? Oh, what else? Ayun, no? Eh, sagot si Andrea, oh. O, yun, no? Si Kim, 1 ba yun? 1? Ah, yun. Yan. Okay, ha? Tingnan natin, ha? 3.25. Okay. Very good. No, 3.25 ampere per second. 3.25 ampere per second. No, this is ampere per second. Okay? But wait, there's more. By Powerhouse calculator techniques. Okay? Will you press in your calculator? No, the shape integral sign. Actually, ito na yun eh. Ito na yun. Tingnan nyo dito. Tingin dito, anak. Ito. O, sige, isusulat ko pa rin, ha? This will be the display in your calculator. D, no? Then, please input 2.4. Focus dito, anak. Focus. Medyo lakihan mo. 2.4, we have 1 minus e raised to negative 10. Instead of t, put it x. No? Because in our calculator, there's no t. Okay. What else? I think we have to put another one here. Parenthesis. And then, our x will be equal to 1 over 5. What is the answer? Will that give you the same answer? Yes or no? Thumbs up nga kung parehas lang lalabas. Please verify muna, ha. Huwag nyo kagad sabihin na parehas, ha. Gusto ko, totoong pinindot nyo sa calculator. Oh, ilan? Oh. Okay. Thumbs up nga kung parehas lang. Ba, ito maganda ang dating, oh. Pinapakita pa, oh. 3.24. Oh, tinagal ni Joel, oh. 3. Ano yan? 3.248046798. Oh, very good. Huh? Okay. Same is the answer. No? Okay. No? Di ba ang ganda nung ganito, no? Merong interaction, ano? Unlike in the other center, wala pong ganito na interaction na hindi pa sila nakakapag-set up po ng ganito. Thank God, tayo po ang una pong gumawa nito. No? Hanggang power system po, ganito po tayo. No? So, enroll na. No? Anyway, meron tayong mga free lecture, kaya lang hindi po lahat ng subject po ay libre po. No? So, yan nyo po, murang-mura lang, no? So, ganito ha, tuloy natin. Ano ang tanong sa number 6? Okay, let's go over to question number 6. VR and BL at time is equal to 0.04 second. Okay, number 6. The question is BR and BL at time is equal to 0.04 second. Oh, by the way, we have to take note of our formula. No? Again. Our formula for I simply equal to what? Okay? Ayan. What? That is B over R 1 minus E raised to negative, no? R over L times T, no? Cross multiply. So we have IR. That is simply our BR, right? That is our V times 1 minus E raised to negative R over L times T. Now, our BR, substitute, how many volts? Total voltage, 24. 1 minus E raised to negative, what is our R? 10. 10, ano? Then, ang sabi, BR at time is 0.04 second. Okay? That will be our BR. I want you to calculate, no? Because I want everybody to participate in the class. Okay? Okay, what is the formula for voltage in the inductor? Huh? What is the formula for the voltage in the inductor? That is our V E raised to negative R over L times T. Our VL is what? 24. E raised to negative 10 times 0.04. Okay? Is that correct? This is our formula. No? Now, I want you to give me the value for BR and BL. I want you to calculate. Of course, I already calculated this, no? I prepared already the lesson plan for this, no? It's just I want to participate, everybody. Because you will never learn if you will not participate, if you will just a listener, no? You're not doing it in your own. So, okay. Let's go to the PowerPoint. I want to see your answer, guys. Is it A, B, C, or D? Na natin. Uy, may sagot na, oh. Okay, meron sagot si schoolmate, taga UE, si John. A. O, letter A siya. O, what about yung iba? O, ayan pala si Camila, ng Bulso. Nasolve mo ba, Camille? Anong sagot mo dyan? Ayun, no? 1 din, no? O, yung iba. Ayaw nyo ba makigaya doon? 1 din. Okay, sige. Ano sagot natin? Okay, letter A is the answer. Okay. So, our BR is 7.91 volts. Our BL is 16.09. How to check if our answer is right or wrong? How to check? Huh? Just check. Right? How to check? Just check? Of course not. The total voltage B is equal to BR plus BL. What is our total voltage? 24. Is that equal to 7.91 plus 16.09? Yes or no? Yes or no? The answer is yes. Very easy. Okay? Very easy. Okay, next please. Next problem. Time when BR is equal to BL. Let's go over here. Number 7. Okay? Baka kumukopya pa sila. Pakopya muna natin to pala. I'm sorry. Sige, kopya muna kayo saglit lang. Ilang minuto lang. Baka, because I see, nakikita ko kung nakungopya sila. Kopya muna saglit. Off muna po na. Okay, let's continue guys. So, our next question is our time when BR is equal to BL. Huh? Okay, let's go over here with in our board. Okay. Close up lang ng konti. Okay, okay lang. Okay. So, time when BR is equal to BL. So, let us set up first an equation of BR is equal to BL. Okay. Our equation for BR and BL is this, no? So, again, our formula, no? Yung formula natin kanina. So, our BR is what? V times 1 minus E raised to negative R over L times T. Okay? Okay, that is our formula. Then we have our BL is V, so E negative R over L times T. No? Okay, so that is our formula. Okay, take a look here guys. What happened to our V? That will cancel out. Right? Okay, so ito na lang ang matitira sa equation natin. We have 1 minus E raised to negative R over L times T. That is E raised to negative R over L times T. Huh? Okay, let us transpose this. Negative will become positive. Okay, take note, they are just the same, right? This one. Negative will become positive. This equation is the same as this equation, right? So if they are just the same, you transpose this one, so there will be 2. Okay? So that is already 1 that is equal to 2 e raised to negative r over L times t. So therefore, we'll be having here 1/2. Okay? Baba lang natin, 1/2 e raised to negative r. Okay? Again, what is our r? Simply 10, no? 10, then our t. Oh, anyway, shift solve na lang. Okay, shift solve. Okay, will you do the shift solve? What letter is your answer here from the PowerPoint? Let's see. Apple, boy, cat, dog. Apple, boy, cat, dog. Okay, what is your answer, guys? What is your answer? Apple, boy, cat, dog. Let's see. I want to see. Sige nga. Wala. Nalobat agad ah. Anong letter sagot niya? Ha?
Lipat sir doon sa problem. Doon sa ano, solution pala.
Ay, sa
Makita.
solution. Nasagutan ko na. So, what is the answer for this particular problem? No? Okay. This one. O, pakita natin dito. This is the answer. O, yan. Naging 1/2 siya. Binabalang natin to. So, e raised to negative 10t. Shift solve, the answer would be letter A. No? That is the answer. Okay? Ayan. Nakuha ba, Kim? Ayun. Kuha ni Joel. Okay. Everybody, please try in your calculator so that you will appreciate our topic. No? Time check.
11:06 a.m. po.
11:06 a.m. Okay? And today is July 3. No? So, live na live po tayo, no? Gandang umaga po sa ating mga viewers sa FB Live. Okay, number 8 question. Okay. We are asked to find PL and PR. No? Number 8. What is our formula for PR and PL? Okay? I will write it down first, the formula. Ah. Okay, our PR, guys, is simply equal to I squared R. Seen it? That is I squared R. That is our formula. Now, our PR, again, what is our current equation nga pala natin? 2.4, di ba? Our time, ha? At time, time natin, ha? Is equal to 50 millisecond. What is 50 millisecond? 1, 2, 3. 0.05, tama? 0.05 second. No? So, this is 2.4. Diba? Yung current equation natin kanina, guys. 1 minus E raised to negative 10t. Substitute ko na kagad. Let us substitute. Okay, our time here is 1. That one. Okay? So that will be our current. But you are going to square this. And then multiply by the resistance. 10. Okay, everybody, I want you to calculate this in your calculator. I will calculate also. So, you have to square this, guys. Okay? You have to square this. Then, multiply by 10. Okay, my answer here is around 8.92 watts. 8.92 watts. Did you get that also, guys? That is my answer. No? 8.92 watts. That is our PR. No? Then, what is our PL equal to? No? So, I will put it here. Okay, our PL is what? Our PL is BL times I. No? BL times I. Yan, ha? BL times I. So, what is the formula for BL? What is our formula for BL? Okay, our formula for BL is our B E raised to negative R over L times T multiplied by I. Okay, so let us substitute 24 E raised to negative 10 times what? T. What is our T? 0.05. Okay? Times I. By the way, I calculated I. What is your value for I? I got approximately 0.94. Actually, this is our I, right? This is 0.94. Did you get this also? That is 0.94. So, I will just put 0.94 here. 0.94. Okay, so what will be our answer for our PL? Okay, my PL is 13, approximately 13.7 or 13.68. Okay, that will be our power. Okay, so So let us see this one, 8.92. Oh, PowerPoint. Okay, in the board exam, kung ano yung malapit. Kung di man natin na isakto, wala naman ibang malapit, kundi letter C. Okay? Okay? A little difference lang dito. No? Kasi galing yan sa review material natin. Walang ibang pinakamalapit yan. Okay? So, the answer would be letter C. Okay? Letter C. Okay? Oh. Siya nga pala, may nakalimutan ako dito sa number 7. I want to go back with number 7. Here. Let's go back to number 7. What is the time? The question here is what is the time when BR and BL will become equal? What is the time? No? I will have an alternative solution for this. No? For number 7, let's have another solution. Because I just saw this in a review material, in a reviewer of electrical transient. Let's go to Marinai's way. Okay? What is the Marinai's way? What is our total voltage? What is the total voltage? Our total voltage is 24 volts, isn't it? Isn't it? 24 volts. Now, what will be the value if your BR is equal to BL? There's no other value than 24 over 2 because they are equal. 12 volts for BR, 12 volts for BL, it will become 24 volts. Isn't it? You get that? Okay. Now, well, the simpler solution is BL. Again, what is the BL? BL is this. So, BE negative R over L times T. Okay? So, ito yung ano. I remember my friend, no? I'm not the one saying this, ha. We are eating in a restaurant. Nakita niya, hirap Englishin ito. Nakita niya kasi yung isang babae. Naaartihan siya. Naartihan siya dun sa babae. Sabi ba naman nung kaibigan ko, kasi na yung formula natin. Ito. Sabi, naaartihan siya. Medyo chubby yung babae. Medyo chubby ba? Medyo mataba. Mataba nga. Ano? Focus mo yung formula dito. Focus mo yung formula. Lakihan mo pa na. Para alam nila yung, baka makatulong lang sa inyo. Sabi ba naman nung aking kaibigan, no? Kasi ang ingay kasi ng babae, ang taba-taba, no? Tapos, naka-micro mini, tapos naka-sando lang, no? Ang sando yung parang fishnet pa. Alam mo yon yung itsura niya, nabivisualize nyo na, no? Sabi ba naman nung aking kaibigan, medyo pasosyal pa yung babae. Sabi, ang arte-arte niya, puro naman siya bell. Ang arte-arte niya, puro naman siya bell. No? So, narinig kaya nila ako? Okay, ha? O, hindi naman lahat, ha? Hindi lahat ng chubby maarte, ha? Nakita niya lang kasi yun, para lang maarte, ha? Arte-arte, tingnan mo yung arte-arte, no? Puro naman bilbil, no? Hiro mo, bulging pa yung mga, yung kasuotan. Okay. So, what do we have here in our equation? Okay. We have here our BL that is equal to 12. That is equal to 24 e raised to negative. What is our R equal to? 10t. Shift solve, guys. Will it give the same answer as before? 0.069. Pakitabi nga natin, anak, yung dalawa. Gusto ko makita rin ito para makita nila yung dalawang approach. There you are. Medyo close up pa. Close up pa. Okay. That one. So, 0.069. Okay? This is approach doon sa libro, sa reviewer, no? And this is the Bell-Bell's way. Okay. Okay? So, that is the formula. Okay, ha? Buti wala si Caris dito, ha? Okay. Hello, Caris. Baka nanonood ka sa Facebook, ha? Hindi ikaw yun, ha? Oh, ito, ha? So, punta tayo dito. Let's go over with ano number na ba tayo?
9.
Number 9. Oh. Kaya ko kasi pinakita, inano tong alternative solution ng number 7. Pupunta na tayo kagad dyan. Wala nang paligoy-ligoy pa. No? Hindi ko na ituturo yung nakita ko doon sa isang libro. Ito na kagad ang technique natin. Number 9, the question is the time. When PR is equal to PL. No? What is the answer? I will not show you the solution in the book. That's too long. That's too long. Let's make it simple. So, our PR simply equal to BR, no? Times I, isn't it? Because power is BI. Remember, we are only referring to DC transient, direct current. Power is voltage times current. So, that is equal to BL times I. No? BL times I. Okay. Take a look. What happened to I? Cancel. Cancel. So therefore now, our BR simply equal to BL. Hindi ba, isn't it that this is the question in number 7 already? Okay, please close up this portion. You see, BR is equal to BL. That is of course 12 volts. I will not show this anymore. So, ganito rin yan. So, the answer will be the same. 0.069. So, our time is equal to 0.069 second. That is the answer. No? Okay, ha? Letter, let's see. Number 9, the answer would be letter, letter D. No? Ayan. Masyadong maliwanag, no? Hindi pala magandang color combination yun. Yung green, ano? Okay. Okay, number 10 to 13. A circuit has 100 volt source is connected to series RL circuit when R is equal to 50 ohms. No? I will draw first, no, the circuit, no, so that you may copy, no, and also, anak, close up mo muna dito sa kanilang ano, para makakopya sila. Okay, so for number 10 to 13, okay, so siya nga pala, good morning po sa mga late tuner natin, late viewer natin sa ating Facebook Live. So how many are they now? 25 viewers. Magandang umaga po sa inyong lahat. This is a free online review, no? Sponsored by MPHT Review Center, the Marinized Powerhouse Team Review Center. So, siya nga pala, ako po si Kuya Reg. Yun na akong tawaging Sir Marinay. Sawan-sawa na ako dyan, no? So, Kuya Reg na lang, no? So, mas maganda kasi ang pakiramdam para mas mapaglingkuran po namin kayo, no? Kasi pagka sir, parang ang taas-taas ng tingin, no? So, ayoko nung ganun magpatawag na, no? Ako lang naman yun, no? Ayoko magpatawag ng ganun. Just call me Kuya Reg, okay? Okay, sige. So that I will be reachable, no? I will be reachable, no? Not unreachable, okay? I am not an unreachable staff. Okay. A circuit has 100 volt source. Okay? Connected to series RL circuit where R is 50 ohms and L is 4 Henry. Question. The current after 4 time constant. Okay, so please focus here. Again, our formula for I will be what? V over R times 1 minus E raised to negative R over L times T. Okay? And then, no? So, the question here is the current. No? After 4 time constant. So, we have here our I. So, V over R. Then 1 minus E raised to negative R over L. Okay, guys? Times T. Then, what is our time? After 4 time constant. So, this is 4 what? L over R. No? So, L over R will cancel. No? Cancel. Okay. So, this will become 1 minus E raised to negative 4, right? Okay. Let us just substitute the value. Our voltage be 100. Our R is 50. Then, paki-calculate natin. 1 minus E raised to negative 4. Okay, so our answer would be letter... sige nga, everybody. Please calculate that one, guys. Please calculate. Anong letter sagot nyo dyan? Apple, boy, cat, dog. Tingin nga sa PowerPoint. Tingin sa PowerPoint. What letter? Sige nga, raise your hand. Ay, nagtataas na yung taga-UE, oh. Sige dyan, oh. Tingnan nga natin kung tama. Okay, 1.963. Gagalit talaga yung mga taga-UE, ha. Okay, schoolmate. 1.9. 1.963 amperes. Okay. That is the answer. Letter dog. Okay, letter dog. Okay, number 11 po tayo. Tayo sa number 11. The time after closing the switch when the induced voltage on L is equal to that of R. No? So, yung time. So, BL is equal to BR. No? So, BL is equal to BR. Naalala nyo yung kanina? Same problem lang ito. Na iba, nag-change given lang tayo. So, what is, ito, dediretsuhin na natin, ha? What is our voltage? 100. So, that should be 100 over what? 2. So, we have 50 volts. No? Okay, ha? 50 volts yan. No? Okay, gagamitin natin yung formula. No? Okay? Again. Itong formula na to, para madaling ma-memorize, ano yon? Ano yung sabi ng kaibigan ko? No? Ang arte-arte niya, puro naman siya bel-bel. Arte-arte niya, puro naman siya bel-bel. Dali, baka mag-out yung ano, ha? Hindi kayo yun, ha? Huwag kayong mag-out, ha? Okay. So, we have 50 volts. That is equal to, what is our V? 100. E raised to negative R. What is our R? 50. Over L, which is 4 times T. Okay, shift solve. What is the answer? Please focus here. I want to hear from them the answer. What will be the answer for number 11? Ayan ha, nakalculate nyo na guys. O sige nga, punta tayo dito sa PowerPoint natin. Okay, what letter is your answer? Oh, ayan, yan. May nagtaas na ng kamay, yung taga-UE. Si John. Ba nickname ni John? Siguro JJ ba nickname mo, John? JJ? Tama ba, JJ? Kamusta, JJ? Nagretiro na. Si JJ Helderbrand. Okay. Ano sagot mo, JJ? Letter B. Ikaw, Joel. Don Joel. Ano mo, sagot mo? Wala pa. Tingnan nga natin kung tama yung sagot ni JJ. Okay, very good. Letter B. 0.05. Okay, sulat natin. 0.0554 second. That's the answer. Letter B. No? Okay, number 12. So, sige, kopya muna kayo habang binubura ko lang yung whiteboard natin. Paki-close up. Ito na. Ito. Dapat makuha rin to. Itong portion na to siguro. Sana makuha yung 9, 10, and 11. Kumukopya sila. Number 9, 10, 11. Yan. Oh. Medyo adjust mo konti po. Focus. Nine, 10, 11. Please copy what is on the board, guys, please. So that you have a copy of our notes. Off mo muna. Now to number 12. Okay, let's have number 12. The energy dissipation of R after 140 millisecond. Or just simply, that is 0.14 second. What is the energy dissipation? No? Okay, let's go here. The energy, okay, basic formula for energy is power times time. No? Power times time. Okay. By integration, this energy is power times dt. Okay? That is the energy. That is dt, that is the integral from 0 to t. Anyway, the time is already given to be 0.14. Okay, so 0.14 yun. Okay, now, ito siya, no? Energy dissipation of R. Okay, so this is ER, this should be PR, right? Yan, okay. Okay, by the way, what is our PR equal to? PR simply equal to I squared R, isn't it? Okay, because that is just series RN. Again, what is the equation for our I? No, our I simply equal to, using our formula, no? What is our, isn't it? O, balikan natin, ha? P over R, that is 1 minus E raised to negative R over L times T. Okay? Let us substitute. What is our total voltage? 100 over R, 50. Then 1 minus E raised to negative R, 50 over 4. Over 4 times T. Okay? There you are. No? So, let us simplify. 100 over 50. So, we have 2. 1 minus E raised to negative. What is 50 over 4? 12.5, isn't it? Negative 12.5. T. Okay. So, this will be our current I. Let us substitute I here. So, PR, that's equal to our I. 2 times 1 minus E raised to negative 12.5 T. Okay. So, that is simply our I, quantity squared. Okay. Then that is multiplied by R. By the way, what is our R? 50. No? Times 50. Okay. Our PR. Okay. What is 2 squared? 2 squared is simply 4 times 50. That is 200. And then, 1 minus E raised to negative 12.5 T quantity squared. Okay. This will be our equation for our PR. No? Okay. So again, for our energy, that will be equal to what? The integral of PR. What is our PR equal to? 200. Okay? So, 1 minus E raised to negative 12.5 T quantity squared, that is dt. Then, the limit would be what? From 0 to 0.14. That is 140 millisecond. No? In our calculator, this is very easy. No? Will you input this in your calculator? No? So, will you move this out? This 200? No? Ilabas mo lang yung 200. No? So, pag nilabas mo yung 200, okay, input this in your calculator. That is squared. You will use your calculator, the integral, of course, the integral, that is shift, the integral, no? Press the integral, and then you can, for the squared, you will make use of square, no? The equation, then squared, no? Input the equation, then squared it, no? Or you may use the x raised to this one, no? Or just simply x squared, no? That's enough already. So, what will be the value? What will be the answer? Let us show the choices. Please answer it. What is our answer for this? Okay. What will be our answer for this? Apple, boy, cat, dog. Apple, boy, cat, dog. No? What is the answer? Para ako naglo-logis dito, ah. Apple, boy, cat, dog. O, sige nga, raise your hand. Ayun, no? Si Joel Cruz, 1, no? Ano? 1,000? Ano? Oh, 1,000. 2,000. Ano yung ganyan? Alam ko, mayroong meaning yung ganyan, eh. Di ba? Sa bungero ito si Joel, eh. Okay, ha? So, what is the answer? Tingnan nga natin. Sagot niya, A, ha? Okay. Very easy. Okay, dali lang, di ba? Okay? Dali lang kung meron anong calculator na yon, ano? Kung wala, that is a long method, of course. But in the licensure exam, this calculator is allowed, no? Okay? Next. Number 13, before we have our break, no? Let's go to number 13. After this, we'll be having our break time. Okay. A short break. It's just a short break. Partner, please ready the PowerPoint. The time when the energy is stored across the magnetic field of the inductor is 7.823 joules. So what is the time, no? When, no, the energy is stored in the inductor. Okay? Energy stored in the inductor is equal to the integral of PL dt. PL dt to, ito, di ba? Okay? So, from 0 to t. In our problem, the unknown is the time. No? But the given now is the joule. No? In number 12, the unknown is the joule. No? The given is the time. No? So, nabaliktad. No? So, okay. So, we have our energy. Okay. By the way, first, I will get first our PL, guys. Let's go over here. PL simply equal to VL. Okay. Then, multiplied by I. Isn't it? Because power is equal to voltage times current. No? Okay. So, again, what is the formula for VL? VL. Okay, bell. Okay. So, eto siya, di ba? Tama ba? Bell. Negative RT. Okay. Then, multiplied by I. Multiplied by I. I will put it in here. So, our PL is VE negative R over L times T. Okay. And then, this is multiplied by I. What is then our I? V over R. This is V over R. V over R. No? This is V over R. Okay? Then times 1 minus E raised to negative R over L times T. Okay? So, our PL now will be B times B, B squared over R. Okay? We'll be having here E raised to negative R over L times T. No? Okay? Times 1 minus E raised to negative R over L times T. Okay. PL is, well, anyway, this is just constant, right? It is just constant. What is our B equal to? 100. 100 squared over R, 50. Huh? By the way, here, please take a look here. I will distribute this one. Here. 1 times this equation is this equation. So, we have E raised to negative R over L times T. And then, take a look. This times this equation minus. Guys, please take a look at this equation. They are just the same, right? Okay? What will happen now? What will happen now? Okay? What will happen? So, this is This is what? No? E negative. This is negative what? 2 R over L times T. Isn't it? This one. Why is that, sir? How is that? Oh, that is just algebra. X raised to A multiplied by X raised to A. What is that? That is X. The same base, what are you going to do with the exponent? A plus A, that is 2A. You are going to add the exponent, right? That is why 2A. That's why I put here 2. Huh? So please focus this. This one. Okay? This equation is the same as this equation. That is why I just put here 2. Let us substitute the values. By the way, what is 100 squared over 50? The answer is 200. This is 200. Okay. This is E raised to negative. What is our R? 50. Our L is 4 times T. No? So, this is minus E raised to negative 2 times 50 over 4 times T. Let us simplify. Please focus here. Please focus. 200 E raised to, what is 50 over, I think we have the value already. Is this 12.5? I think it's 12.5, right? Please focus here. Okay, 12.5 minus E. If that is 12.5, just multiply it by 2. 12.5 times 2, negative 25, correct? Okay. Okay. So this will be the equation of our PL, no? Now, I will have it here. Huh? So, our energy, here, take a look here, this one. EL is equal to integral of PL dt. PL dt, okay. Philippine Long Distance Telephone Company. Okay. So, what is our EL equal to? 7.823 joules. 823 joules. That is equal to the integral from 0 to t. What is our PL equal to? 200. E raised to negative 12.5t minus e raised to negative 25t dt. Okay. Okay. So that will be our equation, no? That will be our equation. Okay. You can have this 200, no? Move it here, no? Ilagay mo na kagad sa labas pag may integral. So that is a constant. Okay, you put the constant here outside of the integral sign, no? So that it's better, no? That will be simplified. Okay? So we have e raised to negative 12.5t minus e raised to negative 25t dt from 0 to t. Now, the question, we already have the energy. In your calculator, you just have to input. You input everything here in your calculator. You replace that t by x. Now, take a look here in our PowerPoint. Okay? The choices is A, B, C, D. These are in second. You are going to choose what letter will satisfy or will give you energy of 7.823. You just have to substitute to our equation. Let's go back to our equation. This is our equation. Okay? So, what? Okay. I will give you time to copy this. 10 seconds. Okay. You copy that for 10 seconds. This equation. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.99, 0.98, 0.97. Okay, let's go back here. What value, if you are going to substitute this second into the integral from 0 to t, we will substitute to t. What value will give you the value of 7.823 in your calculator? Is that A, B, C, or D? What's the answer, guys? Please raise your hands, please. Let's see. Ano, matagal ba magbigay yung calcu? Wala pa. Sana mag-open yung iba ng camera, no? Anyway, magbe-break tayo. Sana mamaya, pagka-resume natin, after around approximately 20 minutes, we will resume, no? So that you have time to eat, no? Your lunch, no? If you want to take your lunch, no? I'll give you 20 minutes to eat your lunch, okay? A short lunch break, no? A very short lunch break, okay? Or you have still time to digest the topic, no? Because it's very hard, no? So we'll go to the next topic, but to the second topic, but you do not know the first topic. It's really very hard, no? That will just bombard your brain, no? That will just it's very hard, no? Too many formulas to be memorized. Okay, what's the answer, guys? I want to hear from you. What's your answer, please? Okay, again. Is it A, B, C, or D? Oh, yes, Joel Cruz. Ano sagot mo? Nasagot na ba si Joel? Wala. Oh, si JJ, yung taga-UE. Schoolmate, ano sagot mo? Bakit wala? Matagal pa? Matagal lumabas sa calcu? Matagal? Matagal niya nilalabas. Gusto na niya mag-break yung calculator. Matagal lumabas, ha? Sige, antayin lang natin. Na-traffic lang yan. Antayin lang natin. Okay, partner, paka-ready yung ating PowerPoint, ha? Sa nga pala, sa ating mga viewers, sa ating Facebook Live, magandang umaga po, no? This is an online free online review, no? Libreng-libre po na online review, hatid po sa inyo na Marinais Powerhouse Team Review and Training Center. Oy, meron na, oh, yun, oh, pinapakita pa sa calculator. Oh, sige, yun, oh, letter C, tingnan nga natin kung tama yan. Okay, 0.36 ba ang sagot niya? Tingnan natin, ha? Okay, very good. Huh? Very easy. Okay, 0.36. That's correct. Let's go over here sa ating whiteboard. T is 0.36 second. Okay? I hope yung ating mga present reviewee ay nakikinig pong mabuti. Please listen carefully, guys. 0.36. Letter C. Okay. That will be the first part of our topic for today. Okay? Sa aming po mga viewers, so kung late po kayo, wag po kayong mag-alala. After approximately 20 minutes, we will come back, no? Okay, so para makapag ano-ano lang po kayo, lahat po tayo, no? Kapag break lang ng kapraso, no? So, pero bago po ito, so meron po muna kaming babanggitin po sa inyong ilang bagay na mapapakinabangan nyo naman po. This is very useful on your part, no? Also, sige, partner. Ipakita natin yung ating PowerPoint dito. Okay. Ayan po. Naka-ready na po. Oh, bakit wala ako dito? Pag yan, sa kanila, kita nila yan. Kaya lang natatakpan ako. Hindi bali na, wag mo na akong pakita. O kaya, takpan mo yung litrato ko, takpan mo. Liitan mo pa ako kasi natatakpan yung wordings doon eh. Medyo liitan mo pa ako. Pwede ba yon? Yan, takpan mo yung mukha ko doon. Takpan mo. Yung pa rin naman, di ba? Okay. Okay. So, we have this. Saktuhin mo na para medyo malaki naman ng konti. May space pa eh. O, yan. Sakto lang. Okay. So, free online REE, RME review and a free marathon webinar. Sabay po ito na ginagawa namin in a week. Meron po tayong dalawang subject para sa online review ng REE at RME rin. Mapapakinabangan din po ito ng mga RME natin. No? Tapos po, tuwing Miyerkules naman po yung ating pong special topic. Yun naman po yung webinar or technical seminar, no? Through Zoom. Libre po yan lahat. On July 7, it will be Advanced Engineering Mathematics, no? On July 8, no, Wednesday, that will be the role of REE and RMEs in construction industry. So, I will do it live, no? So, meron tayong live discussion about ano ba ang role, no? Para ito sa ating mga newly licensed or mga estudyante, no? Lalo na sa mga estudyante natin, pwede po kayo pwede po kayong umattend, no, through Zoom. No, umattend saan? Diyan sa bahay nyo. No, ko-connect lang po kayo. So, July 10 naman po yung ating 3-phase AC circuits, no? Yan na po ang mga Zoom ID natin, guys. Okay. Next, please. Then we have a paid webinar, no? So, we have a free webinars and we have a paid webinar. Baka gusto niyo pong umattend sa aming short circuit calculations, no? So, I will be the speaker of this, no? The coverage is about symmetrical components, three-phase fault, line-to-ground fault, line-to-line fault, double line-to-ground fault, protective relay, no? This is very useful, no? Not only for the student, of course, no? So, priority natin maka-attend ang ating mga estudyante, but also yung ating mga licensed na REE, RME. So, I hope you attend this lecture. This is for you, especially if you want also to become a PEE. Short circuit calculation is one requirement in the board, no? In the board exam of the professional electrical engineer, no? So, pwede po namin kayo matulungan sa parte ng short circuit calculation. Matutulungan po namin kayo, no? Actually, ito yung number one reason kaya maraming nasusunog na building. Tayo lagi sinisisi, no? Mga electrical practitioner. Short circuit daw. Ano yun? Faulty electrical wiring. Pag-uusapan natin iba't ibang klaseng fault. Even there is a very detailed calculation, no? Power system to, no? Sa engineering. Padadaliin lang natin. Gawin lang nating DC circuit yan, no? I will assure you that you will see the easiest way of solving short circuit. Dare, no? This is my dare to everybody. We'll be using the PST. What is PST? The powerhouse sampayan technique. Ayan, no? You know, padadaliin lang po natin yan, sir. Yung power system, gagawin lang po nating DC circuits. Baka gusto nyo po, sir, mura-mura introductory price. Ibig sabihin, ito na po pinakamura niya na i-offer po namin sa inyo, no? On Zoom, online, this is our first batch, pero hindi na po namin paulit-ulit na rin po namin itong nile-lecture po sa powerhouse. Pero sa mga hindi pa po nakakaalam po nito, yung mga technique natin, padadaliin natin ang short circuit calculation, no? So, 1,500, libre na po mga soft copy, saka may mga PDF files po tayo na libre, no? Ayan, tapos may e-certificate. Is good only for 1,500. Schedule, it will be this Monday na po. Itong whole weekdays natin, July 6, 7, 8, 9, and 10. 5:30 to 9 p.m. I'll be solving so many problems, no? Marami pong problem akong isosolve dyan para mas maintindihan nyo po ang short circuit, no? Sabi nga nung mga estudyante namin sa powerhouse, sabi nila, Sir, may isa akong estudyante na lumapit sa akin. Sir, alam mo, when I was in college, I don't understand the short circuit calculation. Nung tinuro mo, sir, ganun lang pala siya kadali, no? padadaliin lang po natin ang short circuit. Di kailangan mahirap, no? Okay? Even REEs, no? I'm inviting the REEs who would like to become a PEE, no? So, this is a very good refresher course for you about the short circuit. In fact, I have a friend, no? So, he got some materials with me, and I think 1 or 2 years ago, he became a professional electrical engineer. Because of this portion, the short circuit, that is one requirement of the board, no? So, I would like to invite everybody, no? REE, RME, especially students of electrical engineering and technology. I will not disregard the technology because this is very important also for you guys, no? So if you are technology graduate, engineering, so you are very much welcome, no? Okay, especially our student, no? Okay, our student in technology and engineering. That is a very napakamura, very cheap, no? Okay? In dollars, that is just how much? The 1,500 divided by 50, how much is the US dollar now? It's just around $30. So that's cheap, no, compared to what you will learn in the seminar, in the webinar, no? Okay. Next is what? Okay, I would like you, so may I request everybody to please subscribe to my YouTube channel so that you will be updated to my latest videos, no? Okay, so please update, no? And please share also. Please follow us and share, no? So this is very useful to everybody, no? So sana po kayo po yung mag-subscribe. Malaki pong tulong po ito, lalo na sa mga magla-licensure exam. Even professional na gustong mag-refresh, no? Even PEE, no? So lately nalaman ko pala ang PEE licensure, meron din palang theoretical exam, no? So not only the TER, the technical engineering report, but also the board is giving some mathematics, engineering science, and ganun din, no? Mag-e-exam din kayo, may written exam, no? So gusto niyo mag-refresh, no? So maganda po, invite ko rin po kayo, yung mga REEs natin na gustong mag-PEE, mag-refresh po tayo mga sir, no? Eh, biro nyo, libre nyo lang po makukuha ito, no? Just subscribe, no? To my YouTube channel, no? Okay, so, next please. Okay, actually, kakatapos lang po ng isang araw yung aming first batch nung aming practical electrical design. Ang tabayanan nyo po, more or less, schedule natin, baka July 13. No, 8 days po 'yan, no? Wala kaming pahinga dito, no? Wala po, no? Ay, COVID, huwag napansinin 'yan, no? Eh karon ka lang ng anxiety diyan, no? So tuloy-tuloy lang tayo, ha? Okay, tuloy ang laban, no? Okay, malaki ginagampanan natin ang ospital, no? Busy ospital. Tanggalin mo electrical engineer o electrician, no? Siyempre yung supply ng kuryente ay mahihirapan sila, mawawala din, no? Kaya somebody to take care, no? Some people, technical people, kailangan po nila tayo, no? Di ba nakakatuwang isipin na tayo'y parte na ginagawa ng mga doctors and nurses because we are the one maintaining the supply of electricity, no? That's very big, laking factor yung ginagampanan natin. Huwag naman lumaki ulo natin, ano? Hindi naman maganda yun, no? Kaya may kuryente dahil sa amin. Of course not. Should not be like that, no? Okay? Hindi tayo nag-imbento ng kuryente, no? Hindi natin inimbento yan. Okay. So, it's Him. The man above, no? Sabi nga ni LeBron James, no? The man above. Okay. So, baka gusto niyo po mag-avail ng practical electrical design po namin. So, ayan, no? July 13 po yan. Ipopost namin sa aming Facebook po yung mga yan. Sige. The Marinay Powerhouse Facebook account. Okay. Next, please. Baka gusto niyo pong order ng aming mga REE reviewers, no? Yan pong 4 na yan, no? Papadeliver po namin for Metro Manila. That is free shipping, no? Lahat po yan ay 3,600 lang po. Murang-mura. Kumpara sa inyong matututunan, no? Sabi nung iba, mahal daw. Oh, napakamura po niyan, no? Kumpara po sa matututunan nyo po dyan, no? So, isipin nyo na lang, para kang nagbi-business, it's just an investment for you guys, no? So, baka gusto nyo pong umorder ng ating, yung mga nakikinig din po sa Facebook Live po natin, makakatulong po na malaki sa inyo itong aming reviewer. Ito pong apat na ito, original reviewer po ng Powerhouse Review Center, ng MPHT Review Center, no? The Marinized Powerhouse Team Review and Training Center. Okay, next please. Ganun din ang Master Electrician, ha? Baka gusto niyo pong umorder, 2,600 lang yung apat na yan, no? Kung Metro Manila, libre na po ang shipping niya, no? May konti lang dagdag, no? Kung province, no? Murang-mura lang po, no? Kumpara sa inyong matututunan, no? Okay? Kasi yung iba tumitingin agad do sa gastos agad eh. Wag, tingin kayo do sa kapalit ng lisensya. Yung 2,600 mo, pag naging RNE ka, lalo't nagbarko ka, sabi, malaki mga sweldo niya, 100,000 yan. Eh, chicken na chicken, what is 2,600? No? Okay, next po. Because I am also a master plumber, pinopromote ko rin po sa inyo ang libro ng Powerhouse Review Center, no? Mga original review materials po, no? Except lang yung plumbing code. Siyempre, code yan, eh, no? Hindi naman ako original niyan. So, yung tatlong libro na yan, so I'm inviting yung aking mga colleague, yung aking mga ka-II dyan, mga kawerpa na mga II, no? Pwede po tayong, ito isang magandang balita po, pwede tayong mag-take ng master plumber, no? So, just send a PM, no? Message, private message, matutulungan po namin kayo to get also. Bago kayo mag-PEE, kahit na lisensyado ka ng REE o kung ano ka mang engineering, pwede kang mag-take ng master plumber, no? Napakagandang lisensya rin po yan. Pwede tayong pumirma ng plano, sign and sealed, no? The plumbing plan. Kung magkano yung mechanical, electrical, fire protection plan per sheet, yun din ang plumbing. It's an instant license, no? Maganda po ang field ng plumbing. It's about water and waste, no? Eh, mamili ka. Walang kuryente, walang tubig. Eh, maigi na mawalan ng kuryente kaysa mawalan ng tubig. Tama, mali? No? So, okay, yun ang pinag-aaralan sa plumbing, no? The plumbing, the master plumber. In-invite ko po kayo, yung ating, kahit ng mga RME, pwede po yan, no? Anybody, high school graduate nga, pwede pong mag-take niyan, yung master plumber, no? Kung wala kayong time mag-review sa amin, online review, by our reviewer, that is only 3,100, yung apat po na yan, no? Okay, next please. Ongoing po yung aming online review, no? Kahit na sabihin mo, napanood mo yung halos kalahati ng review course namin, wala ka naman mga review materials dyan, no? So still, mabibigyan namin kayo at wala tayong webinar or free na refresher course. Hindi po namin conduct po yung refresher course online. That is not intended for broadcast, no? Yung amin pong refresher and coaching, no? Mga confidential lectures po yun, no? Yung mga review course lang po, tapos ilang subjects lang ang aming ililibre po sa inyo. Kaya maganda pa rin, the best kung kayo po'y makapag-review, no? Okay? As low as 7,000 pesos, no? Okay, kung kayo po'y graduate na. Meron kaming special offer sa mga estudyante. Kung kayo ay currently enrolled students, no? Tinamaan kayo ng COVID, no? Hindi ba ako parang nagmura doon? Tinamaan kayo ng COVID. Okay. So, ano po yan? 5,000 lang. No? Kung kayo ay estudyante, kailangan may proof kayo na may registration kayo na 3rd year pa lang kayo, 4th year pa lang, 5th year na hindi pa-graduate. Pag-graduate, hindi na po pwede. No? So, 7,000. Pagka estudyante pa lang, 5,000 lang po. Yung REE review. Kahit RME po, 5,000 lang rin po namin ibibigay. No? Okay, considering marami na tayong review materials din po, no, na ibibigay po sa inyo diyan. And plus, of course, our online lecture, no? Okay, next slide please. Okay, that's it po muna. Hindi pa po tayo tapos, mga kaibigan namin sa Facebook, sa ating mga kawerpa, no, mga kawerpa sa Facebook, wag muna kayong kakalas, no? Kakalas lang tayo sandali para sa 20 minutes break, no? Then go back. Yung pa rin ang Zoom ID natin, no? Kung ma-disconnect lang kayo, yung pa rin ang Zoom ID po natin. Okay? So, let's have a 20 minutes break. Thank you, guys.